welcome Rajesh sir for this podcast. This is a kind of a podcast where I was always waiting to do. Trust me, it's all about not thinking of the AIOps or the MLOps or the system design, which is much more complex over a course of time. It's beyond it, and it's not just a buzzword. It's not a jargon anymore. It's always was there in the industry because when you think of DevOps, it just evolved from the mass production and a lot of stories behind it. So I'm very glad that Rajesh sir is there, and there is always an innate understanding that is required by your side in order to hustle in the industry. Like you need to do this, then what next, then what next. And I think there's nobody other than Rajesh sir who can really give you such great insights about it. And thank you so much, Rajesh sir, for being on this podcast. It means a lot.
Thank you, Vishwa. Thanks for giving me this opportunity, and always happy to share my knowledge around AIOps and what's happening in the world around the IT ops and AIOps. Yeah.
Sure. So let's just start with this question. What is it all about today when we talk about AI ops? And also, is it just a buzzword today, or else what is it all about in the industry today?
Very interesting question. Certainly, it is not a buzzword. Okay, we need to be very clear that it is something which is happening, okay, in the industry, and the industry needs this. Now, what is AIOps? What is your understanding? What is the idea you have about AIOps?
So I feel that it's just ops operations which has all the AI indulged in it, and it's just make sure that the pipeline has hundreds of models deployed, and it's all scalable, it's all monitored, it's all automated to the production system.
Very good. To some extent, you are right. In the sense, yes, operations, right? Operational data. And then we apply the AI, model on top of the data, right? So that is basically what AI ops is, but it's not as simple, in the way that, okay, right, the understanding needs to be a little more. So operational data, right? That itself is a little big world, right, in its own way. So we need to understand what we mean by operational data, right? That's the first thing. And second thing, yes, then we kind of apply AI on top of that. But in a nutshell, operational data will have, structured data, semi-structured data, right, unstructured data, right, and then kind of how AI can be applied on top of this, right, for, certain decision making, right, understanding the data patterns and things like that. So when it comes to, operational data, right, this basically, in this current scenario, the application, that has been developed, okay, it is becoming, getting into a little bit of a, an environment which is little bit more complex compared to our earlier days. Okay, so we used to, have a monolithic based, application development, and then we evolved ourselves into, a microservices based, right, component based, right, and then we want to have, ease of consuming the services, so we move towards cloud, right, and then kind of Kubernetes, Docker came into the picture. Okay, so now in this current scenario, the application environment has, it's a heterogeneous environment. Okay, it's a hybrid environment. Okay, some part of our application will be running on a virtual server, right, or in an infrastructure which is hosted in a, say, client's environment. Part of the application will be, deployed and running on, a cloud. Okay, a public cloud or a dedicated cloud, right, and the application components involving microservices, right, that could be either running on multiple uh, cluster, Kubernetes cluster, for example. Part of the application could be running on, say, IBM Kubernetes cluster, some could be running on, say, AWS and things like that. Now, considering this, the complex application environment, right, monitoring the application performance is a big challenge. Okay. So if you have a single Java file connecting to a database, then you can monitor the Java, runtime, right? And where the Java is running the host, and then the database. It's very simple. Host, you will say that okay, CPU utilization is 60%, memory utilization is this much. Java is doing the garbage collection, right? And this is where the multi threads are getting spawned, and this is where it is getting suspended, and then Java is connecting to a database. Okay, API call is done, right? And then database responds back. So how much time it takes, right? This is fairly little straightforward. But when you consider a scenario, right, multi-cloud, hybrid, heterogeneous, this becomes a little tedious, right? So we need to have a very good observability of the application environment. So that's a first step towards AIOps. So the observability means getting the metrics, CPU utilization, storage, network, memory, right? And then the traces, okay, the services, microservice calls microservice B, microservice B calls C calls the database, right? The complete context of this, okay, this is very important. And then lots of events will be generated, okay, someone changes the password, some services goes down, right? And CPU utilization shoots up, right? All these are all part of the observability, right? Where you have metrics, where you have traces, where you have logs, right? This becomes the input for AIOps. Okay, so anyone who wants to understand AIOps, right, the first step is they need to get a clear picture about the application environment and the observability nature. Okay, how I can observe the performance of my application. So this is the data source, this is the feeder for the AIOps. So you got the picture?
Perfect. That means perfect. And also, I just wanted to ask you this one question because, like, we are talking more of jargons like AI ops, ML ops, DevSecOps, and earlier when you ask the dudes who have done ML ops and the AI ops exclusively, they say that what we didn't do DevSecOps, we didn't do AI ops. AI ops is just a prefix which is just added to the operations. But now when I see companies are transforming entirely, it's like a shift left which we had for the DevSecOps. It's like AIOps is something like there is a new requirement every single time. If you think of a company like Tesla, if you think of a company something like Uber, Ola, all of them are working on self-driving car now, but the way they are deploying is very different over a course of time. So I wanted to know, like, how are we getting in par with the technology which is going on? Because I wish all the IT operations become AIOps someday, and it's so rugged over a course of time. So what is the best practice that any organization need to do right now in order to survive in the industry? Because that's the biggest challenge today when we are talking about AIOps adaptation. So what is it all about when we are transitioning into that AIOps wala situation, and all about that shift which we need to have about the product and everything?
Yeah, very good question. See, my point of view is like this. Any organization, right? They cannot avoid, using AI ops for a better decision making. Okay, from their application standpoint. So the first step is always focus on having a good understanding about the performance of your application. So that is the first step, right? And you need to have a proper mechanism or tool, all right, which will help you to pull the relevant information, data, the metrics, right, the traces from this application environment. So organization certainly needs to focus on this. Why? Because as I mentioned earlier, this is the feeder to AIOps. Okay, so for AIOps or to apply the AI on top of this data, you need to have all the relevant and critical data. Okay, So it is not good enough, if you collect data, right, say for every 5 minutes, right, whatever, okay. You need to take data at least for every second, right? Every second you try to pull the information. So there will be definitely some blind spots within the application, right? To get hold of this spots, you need to have, the complete metrics data, okay. So unless this is not taken care, right, whatever the AI, right, engine or the AI tools, AI frameworks you apply, it may not go well, right? So I will share my screen and I will show, you know, um, see, I'm just showing a tool, okay. This product is called Instana, okay. This is a this is an application performance monitoring tool, all right, and this has the capability to collect metrics in the interval of 1 second, okay. So now this, you know if I show you here, right, so this has, this provides you the complete view of your application environment, right. Under infrastructure, if you go, it will show all your hosts, right, which you can kind of select and monitor, okay, right. You can go to the dashboard, right, whatever that is deployed on that host, right. In this case there is a container which is running, right, and you will see the utilization of the container, right. So in this way, right, every second you start collecting the utilization, okay. This is the feeder to the AIOps, okay. If you go to under platform, there is something called Kubernetes, right. Under Kubernetes you have the complete view of your Kubernetes cluster, right, how many nodes, okay, and what are the namespace that are created and things like that, right. And when you come to the application, okay, so this has a capability to kind of, you know give you the application context. This is also very important. So the before you step into the AI ops, right? First thing, as I mentioned, you ensure that you are collecting enough metrics, number one. And number two, you have a better visibility of the performance of your application. Okay, so this this relationship diagram, whatever I'm showing now, right? This clearly shows that okay, this is a sample, microservices based application, which clearly shows that okay, rating as a microservices is making a call to another microservices, right, and then there's a web server which goes a request to the payment, right, payment goes makes the request to another database and things like that, all right. So this context, application context understanding is very important, right. And third thing is you need to have the capability to understand some of the issues and incidents that happens, okay. So this is the level one, first level, level of screening of your handling of your events and issues that kind of raised in your application environment, right. So my suggestion is enterprises or anyone who wants to get into the AIOps, right, first step, okay, focus on kind of getting all the relevant metrics, right, or the data, okay. See here you see you have option to kind of connect with different log management tool, right, log DNA, Splunk. This is where people will like consolidate, they aggregate their log files, right. What is this? This is your unstructured data for AIOps, isn't it? Now you have metrics here, right, utilization, right, and CPU utilization, isn't it, right. And that metrics are all basically your structured data and semi-structured data, isn't it, event, right. So this is the kind of an input for your apps. So my suggestion is start your journey, right, with good data collection, right, and try to kind of utilize the tools which is available in the market, which will give you the good level of metrics for your next level requirements.
Yeah, that's true, sir. That's true. I think you can stop the share screen, and I think that's perfect. I think such a kind of an application which is built all these days. I think there is always a transition that goes behind everything that we are talking today. When we think of something like as good as an AI system that we are talking, I think probably there is always a need for that system to go down, because we are talking deployment at scale, and scaling is always a thing. And I think what you mentioned is right. But there is always a hope for AIOps to be the number one key for the successful journey for any institution. But are there any still prevailing problems that we are yet to solve today? Because I feel number one, we have ample amount of data which can make a huge database which can go down, which is something like as good as somewhere down the line your database schema can go down. But also there are even challenges today in DevOps itself. So what are some of the problem statements that you feel that is yet to be solved, but it has a lot of scope that it can be solved henceforth? What is it all about when you're thinking of problem statement yet to be solved in the industry?
See, now lots of things are not in standard format, right? And processing this data, okay, needs lots of attention from AIOps perspective. So when we get into the next level in the AIOps, that is basically taking this data, right, and then doing some sort of an uh, pattern recognition, right, and getting into anomaly detection, right, and then for you to give a recommendation for some preventive action. Now the log files, each system, they have their own format structure of the log file. So definitely there is an effort to kind of understand this log file, and then group, right, the relevant events, or pull the relevant information from the log file, right, and then kind of getting into the next level of training, right. This is certainly a challenge. So it becomes a little difficult for the any tool to come out with one single approach, right. So there should be a combination of approach when it comes to a log anomaly detection, right. Once the operational data comes in, log file comes in, you need to do, right, certain number of processing, grouping, right, then only, right, you converting basically that unstructured data into kind of a semi-structured or a structured kind of a data, right, and then get into the anomaly detection, right. And yeah, certainly like the performance of the AI, right, might differ, AI engine, right. So a constant effort is required to understand each of these the log file patterns, right. And certainly that is one aspect. This is purely from the AI, right. And another thing is it becomes little, the architecture becomes little heavy, right. uh, so not everyone can afford to have this kind of a complete full-fledged environment, okay. For bigger the complex enterprise level applications, yes, they can definitely afford to have one complete end to end, right, a tools, right, which gives you the complete data, and then an AI engine which has all the AI capability, whether it is log anomaly detection, event grouping, right, incident identification. These are some of the common features of the the AI ops, right. So okay, for medium segment, right, player, no, certainly it will be become a little challenge, right. And the deployment of these tools also need some heavy environment, right. Yes, so these are all some practical challenges for some of the medium segment customers, right. But from technology perspective, okay, the capability is day by day increasing, where we are able to kind of quickly right? Understand the problem and resolve the problem. That is the core concept of AIOps, right? Mean time to detect a problem, right? And then kind of mean time to resolve the problem, right? So definitely, right, we are heading towards that, and technology is evolving right in that direction.
Yeah, that's true because we are now talking about data meshes. We are now talking about something new in the industry, like something like it's always fresh. The news comes out and it's always fresh. ArcGive has like 150 plus publications every single day. Like, trust me, like that's an at the scale research which is happening in the world. Like everybody has their own problem statement solved. Everybody has a new problem statement which is found, and so on. So we are now transitioning towards a data technology world, which is like everything is data here. Like, let it be no SQL, SQL DB, it's everything is data today. Nobody cares whether it's 100 years down the line or 20 years down the line. What was it all about? Because DB was DB out there, but DB is something which is phenomenal today. So when we are talking about institution transition, like something like, okay, IBM decides to do this for a very long time. How is it all about? But there is always the data. So now you told about collecting data, but how can we become data intelligent over a course of time? Because data centric approach is what we are trying to give for all the AI approaches, ML approaches. So how can institutions like big firms which are actually doing at the scale deployments, like deployment to a next level, like something like other companies do frequent deploys over a course of time, what is it all about when we are talking about a data centric world? And also, when we are going towards the data, how can we manage such kind of an infrastructure? Because AI on the other side is actually a hefty workload on the system, but managing all the deployments, how is it all about when we strategize for this kind of an application?
See, when it comes to data centric, right, um, we cannot avoid that, right? It is data centric.
And also, one more thing, I just wanted to ask you, how are we going to reduce an IT complexity? Because we have tons of data and they say some pattern, and how can we reduce IT complexity as well?
The unfortunately are for to understand, right, to detect something, right, we need to have the relevant data. And when it comes to this application, this operational environment, right, the issues can happen anytime. Now that is the reason we need to deal with collecting all the relevant metrics, right? So what generally happens is, you collect the data, right? And you collect all the events, okay, going through the log file, right? And then you try to correlate, okay, so this event has happened in the log file, and this has happening in the utilization level, and then you raise the incident. Okay, so that is the level of capability now. The tools are coming out, right? Now, in that way, with the amount of data we are collecting, we are trying to bring in some intelligence, right? And then this data, okay, will become a historical data, and you have the option of retain it, discard it, right? And now the policy is we try to compress, okay, and then kind of retain the relevant data, discard all the data, and then store the data for certain period. Okay, so that is the industry approach now, where of course we cannot continue to hold on all the data, right? So every 1 second data will be converted into, say, every 1 hour data, and store it for, say, 3 months, and then you discard it later on. Okay, but in the meanwhile, the system has developed an intelligence to learn, right, the event, right, and the the metrics that are associated with it, and then has the capability to raise incident. Okay, so now the learning has happened, and then you can afford to kind of do away with some data, right? So data is must, right? And learning process happens, right, then yes, you have the option of uh, that retaining or discarding the data. Okay, so that is where we come out with a retention policy, right, for how long we need to retain the data and things like that. And to answer your other question, yes, the complexity increases, right? The infrastructure component, we need to have a good environment, right? And that is a challenge. I agree with you. Okay, so even a simple, uh, deployment needs 16 core and 64 GB RAM and then some 600 GB minimum, right, just to monitor say less than 1000 hosts, right? And then you can imagine if the application level complexity is more, right, definitely you need definitely a larger clusters, right? And that's a uh, uh, that is from hosting all this environment. Okay, now when you come to the AI side, right, training, isn't it, that needs a better environment, a better resource to train. Okay, but lots of things are coming up on that side also. All right, especially uh, from the AI perspective, right, the application of neural network, right, and then some of the ML algorithms. Okay, this combination is used. Okay, so the neural network will be used to extract the features, all right, from the data whatever you have, if it is log anomaly detection, all right, and then SVM is used to find some of the coefficients of whether if it is a classification, right? So now what we can do is we can do this feature extraction in a less compute environment. Okay, and this SVM, which needs a little high computational oriented, right, can be executed in a little high compute environment. Even these days quantum computing is used, right, to calculate this coefficients, right, part of the SVM, right, and then get the things done and then come back, right, to the normal classical world. Okay, so lots of explorations are happening around this area, right? It is a challenge that we need to, right, accept, but certainly different ways are explored, as you might well know that model parallelism, data parallelism, different approaches we have, right, to train the model, right? And now quantum is coming into the picture, so there is a classical quantum combination also is used.
Yeah, that's always there because now we are thinking at the scale deployment, which is like we are deploying data, we are also collecting the data. But now cloud has changed, like something like there is governance as code, policy as code. There is a rapid shift in the way that we are looking at the security. And there's also the way in which we are perceiving cloud is also different. Different. Like somebody like I saw an youngster who really just started the cloud nowadays, and he came back to me and asked, "What is compliance? What is security? Why is organization coming up VNets to just only allow such kind of a traffics to get in?" And I'm like, "What? This guy is talking DevSecOps, but this is what we do every single day." And now AIOps is something which just mingles out with something, but I just wanted to realize like how was the DevOps or the process of operations differing when you think about like 10 years before? Like how is it different today when it's like the DevOps was still DevOps 10 years before, but how is it differing right now with the AIOps? Like what are all the changes that industry has been seeing right now? And what is it all about when we are perceiving some product which is built by an AI today? Because back then, if somebody told me computer had AI, I would have been laughed like, when did computer think better than a human being? But today they make better decisions. So what is it all about when we are thinking of all these aspects compiled together with an AI approach which is given there?
It's a very interesting question, right? See, DevOps, um, that evolved, right, over the period, in terms of how you develop, how you manage your the development process, the release, right, and things like that. So when cloud came into the picture, right, earlier before cloud, our development environment will be different. and then our production will be different. So there is a huge, because of this difference, lots of challenges and issues. When cloud came into the picture, to some extent, we kind of, overcome that. Why? Because our development environment, test environment, and production more or less will be same. Okay. But now in this world of AI, right, the value add, okay. So there is an integration of DevOps, right? Now what happens? Now I have deployed an application, okay. Now it has 10 microservices, and now microservices, one of the microservices is payment related. Assume now it has started giving problem, or some new features are expected in that microservices. So what the development team will do, they will go ahead and modify, and implement that new feature in that payment microservices. Now what they will do, they will deploy that in the production. They will do the test and all the stuff, right? Or assume that okay, they have developed it and they are testing it. Okay. Now the integration of this DevOps, right, with this, AI or the observability. Okay, we have the capability that okay, once you deploy, right, the new payment module, we keep start monitoring the performance of the overall performance of the application. Okay, and if there is any change in the behavior, okay, right, the latency, the calls that has been made, or the error rate, right, call error rate, if that happens, if that drastically increases, okay, this observability will let us know that you know this is happening. Then the next step is okay, alert will be raised, right? And the next step is this alert will be handled by AIOps, right? For the recommended actions or whatever it is. Okay, sometimes it's not necessary to go to till AIOps. Something can be handled over here, right? But this is the the scenario as of now where, right, the DevOps cycle, right, is well supported by this the AI ops, right, in such a way that we will come to know immediately something is going wrong because of our new the release, right? So we can go ahead and roll back. Okay, so that also can be automated, right? Someone can roll back and then kind of put the old release back, right? So this integration, okay, that is something helping the DevOps team a lot, right? So this pipeline feedback, we call this as a pipeline feedback, right? And this is where becoming very interesting, right? So as a developer, you develop, right, host it, and then leave it to these people to kind of deal with the things and come back, right, with the corrective actions.
That's true, because when you think of the way in which we will start developing, I think probably everybody will start talking algorithm went down. It's not like server went down. There is a pager duty notification which says that you made the server cry. Probably they might even change it to something like your algorithm might cry. Something like that, because at the scale deployment that we are talking about, and there is always a chance that AI can unlearn something and relearn something new. Like Tay tweets had an biggest disaster in its entire life. Like tweets were amazing, all of a sudden the tweets were so demonic, and the way which we are developing is also going to change. The way which we are going to testing probably is going to be changing, because now we are talking about CVE, the DevOps, like something like raise a ticket on a CVE. Let somebody just do it. Like we are now trying to DevOpsify the cyber threats which we used to face over a course of time. Something like there is DDoS attack protection, which is always given from all the different network aspects that we are talking today in the cloud. Like every cloud flavor has it. Like today, everybody has it right now. So how is it always going to be about the development and the testing process? Because organizations need to give KT to the engineers who will be part of that cycle as well. And they need to make sure that their product will be as sturdy enough in order to be sitting on that server rack and making sure this happens. And that happens, and it should make money at the end of the day. So how is it all about when we are thinking about the testing and the way which will be developing applications in the AIOps pipeline that we are talking for the tomorrow's world? Of course, it's today's world, but like, how is it going to be there when we talk about the tomorrow's world?
No, it is these days in general, right? It's all agile. Okay, so the cycle has changed, right? We try to come out with a new release every 2 weeks, right? And then the testing process also has changed. So the developers who is developing has a responsibility of doing the testing, right? And the testing team, kind of do the overall testing, right? And then the product is released. Okay. And because of this agile nature, the lots of cycles involving the development and test is reduced, right? And mainly because most of the environment that is required to develop, right, it is same for the developer and the test. So one single effort to get that infrastructure and an environment, right? So doesn't make sense for the testing team to do the same test again, right? So because of this agile nature, some other things are addressed. And then I think the testing also, lots of automation tools have come in, right? And again, kind of AI is applied on that to kind of identify the reason for the defects, right, that are being opened, right? So, definitely, like AI is helping the testing community, right? Uh, One from the agile developer takes the load, another one is from the testing team perspective. They tend to, automate many things, right? Because of this automation approach, okay, they have the scope to kind of bring in AI into the picture, right? So that for them to easily the I know go analyzing the defects that have been opened, right, and coming out with a quick resolution, right, grouping of these defects and things like that, right? So that particular world also, it's changing. So the testing community also is trying to adapt themselves by making use of the AI.
Yeah, that's true. Because now we talk about uh, reliability and resilience in cloud. Like, I think probably 5 years down the line, I've never seen anybody talking too much of the reliability and the resilience, because software architecture defined data center, software architecture defined what networking has to be today. So now when we think of open source software, like, they are vulnerable to one extent, like something like, okay, this is open source, this is open source, this is open source. What next? What's the next biggest threat? Because Apache Struts was also having a huge demand in the market, and all of the sudden it really had a big impact on the DevOps world. Like, many companies had to get the heat of that CV which was raised and so on. So it's all about that when we are talking about reliability and the resilience. That's where we go back to the cloud. And that's where we also rely on the cloud, right? Something like, okay, it's a world-class infrastructure which is always given to me, but there are some things which can go wrong there also. So what is it all about when we talk about reliability and the security? Because we talk about open source and enterprise softwares which are also playing on the AIOps pipeline, like something like, you can have Elastic on it, which is paid, but you can also have other applications which are open source. So what is it all about when we are playing a part in really giving such a resilient and a reliable architecture to the world through all these things that we are talking about?
So why you suspect that using open source may not be reliable?
It's like, it's an open access to everybody. Like, anybody can do a PR there. Anything can go wrong. Like, somebody might indirectly, like something like Jenkins, you won't get to know that there is an miner running on your pipeline only. Like, something like, there is a blockchain miner which is running, because when we see companies which are doing deploys to that extent, probably they have more vulnerabilities than what a company which does less of the deploys. But to some extent, when we do a lot of deployment, we find out there is a lot of errors. But open source is somewhat which is open to everybody, and I think nobody is being charged of it. Just like something like we saying that, yeah, I just made a mistake. It's not my algorithm. Like something like we didn't have enough data. We can just put some reason on it. But when the open source goes out, like it's terrible. Like everybody is affected because of that one reason. So that's where AI open source is something which I
My
really.
my only response on that is, change the perception. Okay, it is not like that. Okay, open source, has made our life easy. Many products still continue to use open source, open telemetry, right? Open tracing. Okay, these are all open source contribution used by many of the application performance monitoring tools. And when it comes to AI, right, lots of the AI related algorithms, models, right, even the data sets, right, contributed by the open source community, right, is well used, right, by many organizations. Okay, and they have created so many models, made it available as a container, and it's easy for us to consume. So my strong message is, we should encourage, okay, using open source, and the people who are consuming it should be aware of the level of challenges they may face with that, right? If they are not confident, right, with that, then probably they should have an alternate option, right? But definitely, the contribution, right, made by open source community, right, it's something very huge, and I encourage every one of you, like every one of us, right, should consider contributing to open source. Lots of technologies are adopted from open source, right? Yeah.
CNCF has their own standards also. Like if the code is not satisfied, they'll not just commit it. They'll reject the PR directly.
Yeah.
So what is it all about when we are trying to build resilience and reliability through all the software architecture and the pipelines that we are talking today?
No, that's a separate practice, right? SRE practice, so people should be aware of. See, it is like this. One team focus on building a product, coming out with new features. They are all excited about that. But the other team, okay, especially the SRE team, okay, site reliability engineers, they are concerned about, okay, what is the the service level, the objective, right, that we can define for this application. So it is a balance between the innovation and the the product availability. Okay, if we want to be innovative, we will try many features in our application, right? But that may prone to break or destabilize the performance of our application, isn't it? So that is why these two, the development and SRE team should go hand in hand. Okay, they should not work in isolation. Okay, if the development team introduce a new feature, the SRE team should have the visibility of how that feature is performing, on what basis I can define the service level objective, right? What should be my the error budget? Okay, right, these are the some of the considerations they should do. Okay, so that is why these days, again, some of the APM tools, for example Instana, what I mentioned, right, has the capability to connect these two. Okay, so now the SRE will be little confident. Yes, this feature is required, but by having this feature, we can attain 99% of availability of this particular application or component or service. Okay, they will take this decision based on the the data that has been collected. Okay, so right, manually it is difficult, right, for the complex application. That is why we want a better tool which will collect all the relevant metrics, right? And then which will help us to take that decision. Okay, so that will tell, okay, this is something 99.9% is available for this period of time, right? Then we can go ahead and have the SLOs and SLAs, right? So that is how basically it is approached. So the decision is taken completely purely based on the data, right? And as I mentioned, the balance has to be struck between the new feature and the availability of our reliability of our the application.
Yeah, that's true. That's true. I think Mark Anderson said software is eating the world, but it defined what the world has to be. Like network, data centers, everything is software today. I think. Thank you so much, sir. Thank you so much for such great insights. And I think probably this is one of the best possible way in order to understand. Okay, this is what is happening in the industry. So right now, don't judge the industry so early. And I think thank you so much for such great insights. And hopefully every institution transitions for an AIOps approach. And thank you so much, sir.
It's my pleasure, Vishwa. Thanks for giving me this opportunity. Hope you find this information useful.
Thank you so much, sir.